To solve a triangle means we must know all three angle measurements and every side length. That means we know everything about the triangle there is to know. Now, for right triangles, we really need to know either there's another angle and a side, or we need to know both sides. Then right triangle trig is all we have to have for the rest of them. Now, for triangles that are not right triangles, these are called oblique triangles. How do we solve those? Well, for right triangles, we actually have three pieces of information. We have either the angle and a side, like I said, two sides, and the fact that it is 90 degrees. That is a third angle. That's a third piece of information because it's a right triangle. And we will need three pieces of information for oblique triangles to solve those as well. We're going to need to know different kinds of techniques to solve those things. What kinds of information can we need? Well, there's really one case of things that we cannot have, and that's what I have laid out here. I have a right triangle where I know all the angles, but none of these side lengths. If you do the right triangle trig on either of these angles, 50 or 40 degrees, we get this. And there's no way to solve this. Because we don't have any side length, we cannot solve for any other side length. And that's because if you know only the three angles, there are infinitely many triangles that satisfy that scenario. Now, if we do know at least one of the side lengths, then we can solve it. And really, there's six possibilities of known information, and that's what I've shown here in this table. There's if you know all three sides, two sides and an angle outside of that, side angle side, so it's two sides with an angle between those two sides, a side and then two angles, angle side angle, so two angles and a side between them, and then of course angle angle angle, which is what we had up here. Angle 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 you cannot solve because you don't have any side measurement and you need to have that. Now, how do we solve these? Well, we cannot use right triangle trig to solve oblique triangles because they're not right triangles. However, we can use right triangle trigs to find us a technique to solve it. So for any triangle, you can always put the longest side. For any oblique triangle, you can put a longest side or one of the longest sides on the bottom and create a shape like this. So doing that, we can create a line straight down and we can get a height from that. And this creates two right triangles, a right triangle there and a right triangle there. Well, we can use the fact that sine of A is going to be opposite, which is now this height here, h1, over hypotenuse. That's going to be C here because the hypotenuse is always opposite the right angle. That gives us, just rearranging it a little bit. And then we can take sine of this angle, C. The opposite of this angle is now h1, as you can see here. And the hypotenuse of this right triangle is A. And rearranging that a little bit, we get this. But notice we have h1 and h1. So I can put C equals sine A and A equals sine C together, dividing the side lengths over, we're going to get this portion. And this is the first part to law of sines. But we can go further. Depending on the type of triangle we have, we can rotate it. And we can get the following here. If we do that, we're going to get either this or this. Notice that it's essentially the same thing as this, but the different side lengths are changed. Sometimes if you rotate it, however, you'll get the top hanging off the base, which then it won't look like this, right? The height won't go through the triangle. It'll actually go outside of the triangle. This creates a little bit different of a scenario, but we can still get the same solution. So to solve this, we're going to create a right triangle by dropping this straight down and then extending this base over. That gives us this right triangle that I label here. Now, this is a straight angle. Straight angles are always measurement of pi. So this angle specifically is going to be pi, the straight angle, minus this angle b. That's what I have here, pi minus b. And doing sine on C, this angle here, this is a right triangle. Sine is this big right triangle here. Sine of this is going to be opposite, which is H2, over the hypotenuse, which is B. And rearranging that, we get this statement. All right, from that, now we can look at this right triangle. Sine of this angle is going to be opposite H2 over the hypotenuse, which is now C, for this smaller right triangle. For the bigger right triangle, it's B, but for the smaller one, it's C. So we get this statement. This is a difference inside, a difference of two angles inside of a sine. So we have a formula, a trig identity for that. That's this one right here. So all I've done is expanded this statement into this. Well, sine of pi is just 0. Cosine of pi is -1. Cosine of b is actually a little bit hard to find, but we don't need to find it because 0 times cosine b makes it go away, so we don't have to worry about it. Sine of b is exactly what we want, actually, because we have sine of c and b. We want sine of b here. And that's what remains. Negative times negative is positive, and we get sine of b equals h2 over c. Rearranging that, we get this statement here. h2, h2, we can combine them together, and that will end up giving us this statement. And I've looked at I've considered every scenario. Therefore, we can say it's true that the law of sines always holds no matter the oblique triangle. This is the case that we have. It's important to note that this law does not work if we only have one piece of information from each of these ratios. So if we have the side, 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 for instance, we don't have the other side of the ratio. We cannot solve this using law of sines. Or at least we need to find information another way to do so. If we have side, angle, side, or for instance, side, angle, side, you know, whatever combination you have, you need to know an angle and the side opposite to use the law of sines effectively. So let's see that in practice here. We have a triangle here, and we have angle, side, angle. That's what this is read as. So this is angle, side, angle. And we do not have a side and angle opposite, right? I could say this is, let's do A, B, C. What I know here, I know this would be C. I would have, this is A, this is B. I know A over sine A is 22 equals B over sine B, which is 111, equals C over sine C. Note that I flipped everything from the law of sines. I put the sines on bottom and the side lengths on top. It doesn't actually matter which way you flip it because you can take the reciprocal of everything here and flip it all around. It's actually fine. You can do whichever way is the easiest for you to do the calculation, do it that way. But you can see I have one piece of information from each of these things. I have this one, and this one. So I cannot solve this using law of sines. However, I can use the fact that triangles, the angles have to add up to 180. And 180 minus 111 minus 22 gives me 47. So I know that sine C equals 47. So I actually have this last piece of information. And now I can use law of sines. So I'm going to use what's given to find what's not known. I have, let's start with A. So we know, we don't know what the side length A is, but we do know what the angle side A is. Angle of A is 22. And this equals, we know everything about C. So C is 8.6. That goes on top with the other side length. And sine of C is 47. The only unknown here is A. So let's solve for A. I'm going to multiply sine 22 over. And now we can just plug everything into the calculator and solve. All right, I get 4.4 yeah, with 2 places of information. So 4.4 is my side length there. And B, I don't know what the side length of B is. I do know what the angle is. I know what C is from the information given, so I'm going to use that again. I could use A, but because I found this one, I'm going to, if I use it in my calculations, I'm going to further the error measurement. I'm going to further make it off because I approximated 4.4. So I know 8.6 is given to me, and 47, because that's the calculation, is exact. There's no need to worry about using that. Okay, it tells me that B equals 8.6 times sine 111 over sine 47. Plugging that in, I get 10 point, actually it gives me 11.0. And now I have all the information known. B is 11.0 and A is 4.4. So this triangle is completely solved, this oblique triangle. All right. For this one, I have a side and 2 angles. So this is going to be a side angle. And let me give this names. That doesn't really matter. Let's do like A, B, and C. This is going to be what B equals. This is B, this is C. I can find the third side. I'm going to do that. I don't need to do that right now because I know what the angle B is and the side opposite. But since I can find that really easily, let's just do it. 180 minus 53 minus 42 gives me 85. Okay, now we can use law of sine. So A and C is what we're trying to find. Let me flip the law of sines and show you that way. So we get sine of, see, we know what B is. So B is 42. The side length B is 6.7. This equals sine of, let's do A, 85, over the side length A. So to solve this, let's cross multiply. So we're gonna get A sine 42 equals 6.7 sine 85, then divide by sine 42. So okay, plug it into a calculator. It's going to give me 9 point, if I round it to 2 places, it's actually going to give me 10.0. And had I used this instead, had I flipped this, so made 6.7 over sine 42, A over sine 45, I would have actually only had to do 1 step to get the thing. I wouldn't have had to do 2 steps. That's why I prefer flipping it to using exactly what I need. And really what you want is the unknown in the numerator. Be that sine or the side length, whichever you're looking for, that's the unknown you want. So to do that, let's look at solving for C. I have B. I'm going to put the side length in the top because I'm solving for a side length of C in the top. The angle is 53, opposite C. And now to solve this, all I have to do is multiply by sine 53. So C equals 6.7 sine 53 over sine, this was just 42. So no cross multiplying like I did here. I just immediately solved for it. Okay, solving that, 8.0. And this triangle is completely solved. We have A was 10.0, C was 8.0. Everything is known about this triangle. Okay, let's look at this kind of problem. We have the roof of a house has an angle of 20 degrees. That's what this is saying here. So if you take the horizontal, the roof goes up 20 degrees. And an 8-foot solar panel, that's what this is right here, this gray thing, is mounted to the roof, and you want it to be at an angle of 35 degrees relative to the horizontal for optimal results, which is really optimal sun coverage. So like it faces the sun for as much of the day as possible, which gives you the most solar energy as possible. So how long does the vertical support, does this thing need to be for the panel? So really this is going to be our X. And what we're looking for is, or I should say what we have, is really we have an oblique triangle here. This is the roof, and this is the vertical support. This is 8 feet, and this is, so doing this, this here is 38 feet. So we have this oblique triangle, and we're asking what's this angle here? Or sorry, what's this side measurement here? Well, we actually know that between this is the roof, right? The roof continues. And this is actually 20 degrees, which means we know that this angle on the oblique triangle, this angle must be 38 minus 20, so 18 degrees. And all we're trying to do is figure out what is X here. Well, there's a couple of things we can do. This was the horizontal, so that makes a right angle. And that's important because if this is the right angle, and we know this full angle here is 38 degrees, that means we can find this angle here. And we need to find another angle. We only have a side and an angle. We don't have enough information to solve a triangle. We need to have a third piece. But I can create a right triangle out of this horizontal. I'll just show you on the drawing here, right? This is a horizontal. If I continue it this way, this is also horizontal. That means this one has to be a 180 degrees minus 90 minus 38. And that gives me 52 degrees. Okay. And here we can see we have an angle side angle triangle. We're trying to find this side here. Well, to find this, we need to know the angle opposite the 8. So we have to know this angle here. Well, that's once again 180 minus 18 minus 52. That gives me 110 degrees. And now we can find X by using the law of sines. So we know 8 over sine the opposite angle of 8 is 110 equals X over sine. The angle opposite X is 18. So we're going to have sine 18. That means X equals 8 sine 18 over sine 110. Okay, plugging that in, we're going to get, gives me 2.63 feet. So that's how tall the support needs to be to get the correct angle of 18 degrees off of the roof for this scenario.